Hey everybody, there's been a couple of questions about the 176 lab, specifically regarding things like which parameters do I pick, how many do I have to choose, and do I really have to do all of those? The answers to those are what I'm going to try to provide now. Which parameters do you pick? Try to pick the ones that would be relevant for some kind of hypothetical control scheme. So if you go look back at Canvas, you'll see that the idea of the model is that somebody in a process environment has handed you this model and said, you know, we either have this reactor and we want to control it better, or we're going to buy this reactor and we're trying to control it better. And so it's up to you to choose parameters that you think are controllable and then provide some explanation as to why. So for example, there could be a bad choice, right? You could, well, it's actually worse than bad. It's a wrong choice. If your study looks at how the effect of molar mass of silicon affects the deposition rate of silicon, that would be a bad study, right? Because we can't vary the molar mass of silicon. That's not something you can vary. You can do it in the simulation, but we can't actually do that in a real system. There are other examples that would be doable, but not really a good choice. So for example, maybe you would want to vary the flow rate of gas in a particular bend inside of the reactor. And it's like, well, that's physically possible, right? We can manipulate that, but we have no controller by which we can sort of reach into the reactor and slow down a molecule in a particular place. Oops, I just bumped my microphone. And so that would be physically reasonable, but kind of a bad choice, right? Because we don't really have a controller for that. And so you're left with the things that you would have come up with in your controls class for the typical temperatures and pressures and flow rates and compositions and things like that. The justification for which ones you choose can either come from literature. So if you can find somebody else that has said this value is important, then you can use that. But you can also justify it as this is one of the controller mechanisms that we've learned about in the past. And so you can link to, or you can cite a controls type textbook and say, yeah, these are some of the common ones. How many do you need? Something like half a dozen is a good number. So with a 2K analysis, if you do 6 different parameters at 2 levels, you'll end up with 2 to the 6th combinations, which is 64. And that can seem kind of daunting if you have to run a COMSOL simulation 64 times and manually select every one of those, but you don't have to. So at the end of the second COMSOL lecture, we had mentioned the utility of a parametric sweep, being able to do that for you automatically. And so what I've got here is our double pipe heat exchanger model from our homework 2 for COMSOL, or sorry, homework 4 for COMSOL. And I'm just going to use this as an example of how you can do a quick 2K sweep. So under study, if you right click and say parametric sweep, you can add parameters here. So I've added 2 parameters to our system that represent the inlet water temperature and the inlet ethanol temperature. So I'm going to add 2 parameters here. I'm going to change the drop downs to the ethanol coming in, which was our cold stream, and our water coming in, which was our hot. I can provide a list of values here at which I would like to evaluate the model. So maybe the ethanol is 290K and 300K for my 2 levels, and my water coming in, which is the hot one, could be maybe 350 and 360K, something like that. And then the key point in a parametric sweep, change this sweep type from specified combinations to all combinations. If you leave it unspecified, it'll just sort of take like the first row and say evaluate the model at 290 for ethanol and 350 for water. And then it'll do the next one 300 and 360, and then it's just that. It won't do any more. If you do all combinations, though, now it will really do all of those combinations, right? So 290 and then at 350 and 290 and 360 and 300 and 350 and 360. It will do all of the possible combinations, which is, if you've only got 2 levels, going to be the equivalent of a 2K parametric sweep. So I'm going to go ahead and run this. Hopefully it won't take too long. Let's go ahead and click compute. Okay, there we go. So I just ran a 2 to the k, or in this case 2 to the 2 parametric sweep. The processing time was not particularly long. If I go back and look at the time somewhere up here, it took 13 seconds, right? It doesn't take terribly long. Even if it were to take 20 minutes, right, you just hit the run button and walk away and, I don't know, go have a coffee or something like that, whatever you like to have. So then when I want to export the data, I've got the data set up down here to just export temperature. Yours would be that delta SI parameter inside of your system, which, by the way, I'm doing this deliberately to not make it just so that you have to follow the video, right? I'm just telling you general guidelines. Make sure that the appropriate solution is selected. So if it's the only one that you've run, it'll just be solution 1, but double check the data set here and make sure that none of these say parametric sweep. If one of them says parametric sweep, take that one. You'll know that you did the parametric sweep because the data output here will allow you to select which one of them you want. And I usually just say all of them. Then once you go ahead and export this, the data file, you can open it as a text file and, like, I don't know, copy paste it into Excel or just import it into MATLAB, but I did it here in Excel just so that you can see it. What you'll get is instead of just 3 columns, so if we had just run it at one setting, we would have just 3 columns. But now we have an additional column for each of the pairs that we have. And up here at the top, it'll tell you, okay, this was run 1, and it was for ethanol at 290 and water at 350. The next one was 290 and 360. Next was 300 and 350, and the next was 300 and 360. Right, so this is all of the possible combinations. When you do a 2 to the 6th, if you do like half a dozen parameters, you'll have 64 columns here, which again sounds like kind of a lot, but your goal then is to just ask MATLAB to analyze each one of those columns in order to get your effectiveness factor. That's why the script was provided to you, and it was also why the script was provided to you with the analysis function given at the bottom, in case you want to take that function out and put it inside of another script or a function that'll let you analyze a data file like this a little bit faster. But that part is sort of up to you, right? Once all 64 of these columns of data come out, then it'll be up to you to figure out how to do those 64 columns of data. Another key idea with 2K analysis is we don't have any replicates with a COMSOL model. If you were to replicate anything, you'll just end up with exactly the same numbers because there's no noise. And so to get around that, to add some degrees of freedom to our error in the 2K statistical analysis, we'll neglect anything higher than a second order interaction. So if you have A, B, and C, the only interactions we would look at are A and B and C and C and A. And then the higher order interactions like A, B, C, those all just get stuffed into the error degrees of freedom. So I hope that is helpful for you and that it'll sort of speed up your 2K analysis. If you have any questions, please let me know. Thanks all. We'll see you soon.